Hi everyone. In this video I'm going to be covering the hands-on activities, the hands-on labs from Chapter 9 out of the CCNA Routing and Switching Study Guide written by Todd Lamel. To begin, I'm starting in Packet Tracer, so I'll need to build my topology based on the topology pictured at the beginning of the hands-on labs. So we have 3 routers and 2 computers. We could add an extra computer here for a final connection. I'm not going to worry about it though. We want to go ahead and get them cabled together. Before we can cable serial interfaces on the routers, we first need to add the serial interface wick. So we will do that. Fast forward time, let the routers reboot, and then we're going to start cabling. So we want a DCE connection here to here, and then another from router 2 over to router 1. And then in Packet Tracer we need to use a crossover cable from router to PC. Alright, and there's a little bit more work to do before we're ready to begin the hands-on labs. We need to do some IP addressing and bring our interfaces online. So I'm going to go ahead and start with the computer. Just change the display name so we can see that A is working with A. Lab A will be the router. You need to go ahead and set a static IP address. And I'm going to make everything just a standard class C. Even though my addressing scheme may not match exactly, and I certainly wouldn't need a full class C for a point-to-point connection like this, but just for simplicity. So this should only take a few minutes. This is going to be 20.1. Again, just building it as a class C. On the serial interface, because we did set up as a DCE, we want to set a clock rate. And I'm just going to set it 128,000. And then we want to jump back into both and make sure we give them the no-shut command to bring them online. And you saw the light switch from red to green here. Still red here because this end is down. So that'll be the next thing that we do. Get an IP address. This should be 20.2. And it'll automatically pick up the clock rate from the other end. And 001. Alright, so this one came online. This one's still down on this end, so we'll continue. And the LAN interface. Sorry, I see that command got kind of split up. I'll go ahead and just bring it back. There's the full command for that IP address. It'll also be the gateway address on this interface here for the LAN network. Alright, and the last thing is to configure this PC. Alright, now we should be able to ping from the PC to the directly connected router, and directly connected router to directly connected router. Because these aren't requiring any routing protocols, it's just point-to-point that we're testing. So we're good all the way there. And that's just the basic topology that we're supposed to be starting with for this. So now, Chapter 9 was all about OSPF, configuring the routing protocol, how it functions, how it compares to other routing protocols. So the hands-on labs really are just about enabling, configuring, and verifying OSPF. So we'll go ahead and get started. 9.1 and 9.2 go hand in hand, enabling and configuring. I'm going to do them kind of combined all at once here. So in 9.1, all you're supposed to do is give the command to enable OSPF, which is router OSPF, and then an ID number for the process. So I'll give 100 on lab A, 101 on lab B, and 102 on lab C. And so that's 9.1. 9.2, now we need to configure it. So on lab A, we're going to create a network statement for this network and another for this network. And so we're going to use the interface that is directly attached to that network, or that points to that network. So the 10.1 is the gateway, it is this interface right here. And then we need to use the wildcard subnet mask and put it into an area. This is going to be a single area OSPF, so everything will fall into area 0. Then the other network statement will be the serial interface. So that's all we need to do to get OSPF working on the lab A router. So next we need to move to the lab B router, and we're going to kind of do the same thing, except in this case it's just two serial interfaces. So that tells it about this network and this network for routing purposes. And then we're ready to move over to lab C. I don't know why I hit exit there. We still want to be in here for the network commands. And we want to tell it about the serial network and the LAN network. So the first one came up, interrupted the second command. I'm going to go ahead and retype the full command here. And now we should be able to route communications across routers, all the way across the entire network. Alright, so that was 9.1 and 9.2, kind of back to back fairly quickly there. 9.3 is all about verifying the OSPF operation. So again, we'll start with lab A router. And we're going to give the show IP OSPF neighbor command. There we go. And so we see that 30.1, which is actually this interface on lab B, so it's showing as a neighbor through that route. 20.2, which is this interface. And we had 20.1 here. So now lab A knows how to get to this network by using this route. So let's go ahead and give a show IP route, and we can see all the networks that it knows how to route. So we do not have a gateway of last resort or a default route, anything like that yet for all unknown traffic, or all traffic that's not destined for one of our known networks. So if we had any traffic that was destined for a network not listed here, those packets would just be dropped because we wouldn't know how, or this router wouldn't know how to get those packets to that other network. If we were trying to use like a 192.168 network, it has no idea how to get to that network, so it would just drop those packets. But it does know about all of these networks. It has a directly connected 10.0/24, which is the LAN. And this is actually the gateway interface on itself. It knows about the 20.0/24, which is the serial interface over to Lab B, so this network. And again, the local code shows that is the interface on that network. And then, because of OSPF, it now knows how to get to 30.0, which is this network, and 40.0, which is this network. So using OSPF, it's learned how to get to these other networks that it can't directly communicate with, and it has to be routed. Alright, so we can go ahead and give the command show IP protocols. And this just reviews the OSPF protocols that it's using. So we have the router ID will be the highest IP address unless we manually set an ID before we set any IP addresses. So if we wanted to change that to use a different router ID, we would need to go do that manually and then reset the OSPF process. The ID is used a little bit more in multi-area OSPFs. It's also used for configuring like standby routers or just lost my train of thought there. Determining priority, if there's going to be any kind of priority in which routers are going to be taking over well, the router ID would also allow the routers to determine the best routes. Some of the protocols are based on the router ID for determining the best route when you have multiple routes for redundancy. When I get into a multi-area OSPF, I'll try to go a little more in depth in that, and we'll take a look at how that affects the process and the routing of traffic. In a single area, it's not terribly important. One other thing to note about the router ID is that if you set a loopback for the OSPF process, it is, I believe, a best practice recommendation. Your loopback will probably be a fairly high IP address, and it will show up as the router ID unless you manually configure a specific router ID. So that really just allows you to kind of control the paths that your traffic will take in your network when you have multiple paths to different networks, so you have redundancy in place. Okay, so moving on from that, I mentioned this very briefly. I want to take another quick look at it. The process ID of 100 here, on the network, it's actually pretty irrelevant. This only helps to identify locally on this router that OSPF is running with that process ID. The other routers, they don't care what that is. They only care about the router ID itself, not the process ID. So keep that in mind. The protocol will also show us the directly connected networks, or the networks that we have programmed into the router with our network statements. And then it'll also have the other router IP addresses. So it has its own here. It has the Lab B router here and the Lab C router here with default distances of 110. As it mentions right there. Alright, and then we'll go ahead and give the command show IP-OSPF. And it's again some of the same information, the process ID, the router ID. A lot of this is a lot more in depth than we need to get to in this video, so I'm going to go ahead and skip a lot of it. Number of areas in this router is 1 because we said everything has a single area OSPF. When we get into multi-area, we should see that change a little bit as our routers start to cross boundaries. And our last command, I think, is going to be show IP-OSPF on interface G00. And again, a lot of the same information: address, process ID, router ID, network type broadcast, and so there's no designated backup router, so we don't have any redundancy to get to this network, which is usually a bad thing. But we can also use this command, show IP-OSPF interface, and then the LAN interface in this case. Really important is to verify our timers. So we have a hello, dead, and wait. Usually it's fairly important that these match between OSPF routers. If they're off significantly, for example, if another one had a 60-second hello, well, then this one would think it was dead, as in the link was dead, because it's not getting that hello frequently enough. So I think it's the last thing they want us to look at, is making sure that these match between our routers. And these are the default settings, so they should match between all three. I think it pretty much covers most of the basics of Chapter 9. As always, thank you so much for watching, and if you have any questions or comments, please feel free to leave them for me below, and I'll try to reply in a timely fashion. Thank you so much for watching.